What is a function? Well, here's an example of a function. It takes an input and gives an output. So for example, if the input is, let's say, 1, what's the output? Replace the x with 1. It's 1 squared plus 2 times 1, take away 1. You can put this in a calculator. Replace x with 1, so that's 1 squared. What I'll do, where this x is, I'll just put brackets. They're like placeholders. So those brackets represent the x's. That's where I'm going to put the 1. Okay, so that's 1 squared plus 2 times 1, take away 1. Output is 2. So for example, if the input is 2, replace these with 2's. Output is 7, etc, etc. You know, I could try 3. So when the input is 3, the output is 14, and so on. You can do this for any values, even decimal numbers, fractions, whatever, negative numbers as well. And then what you do when you got a string of values, that, for example, that one there would be 1 along the corridor, 2 up the stairs, and you plot that on a graph. 2 along the corridor, 7 up the stairs, plot it on the graph, and so on. And once you've plotted it, you can join it up with a smooth curve. Here's the graph of y equals x squared plus 2x minus 1. You can see here, that's the lowest point. The lowest point is negative 1 along the corridor, negative 2 down the stairs. That's the lowest point there. And the roots of the graph are right here. That's one root over here where it crosses the x-axis, and here's the other one. That's the other root. You can represent this function like this, f of x. So that f of x represents that one. Right, so as I said, this f of x represents this one. These have got x variables, that's why there's an x inside the bracket. And x can take any values like 1, 2, 3, and so on. So when x is 1, remember the output is 2. When the input is 2, the output is 7, and so on. Now what happens if now I change this function? I take that, but this time I'm going to add 2. So I'm adding 2 to this function here. So now I want to see what happens when the input is 1. When the input is 1, what the output will be, right? So these will change now. Replace x with 1. Right, that's the original one. Remember, that's the original one. But now we're adding 2, this extra 2. So now plus 2. So when the input is 1, when x is 1, output is 4. What about the 2? So when the input is 2, i.e. when the x is 2, output is 9. Try 3. So what you then do is you plot 1 along the corridor, 4 up the stairs, 2 along the corridor, 9 up the stairs, and so on, right? I want to see what that looks like as a graph. Right, as you can see here, this is my f of x, and it represents this one here, x squared plus 2x minus 1. It's what I had originally, and that's the graph. That's the original graph. But I want to see now what happens to this when I add 2. What I'll do, I'll copy that, create a new one, but then I'm adding 2. Now you can see now there, this one over here that I'm tracing, that's the f of x plus 2. Now what I'm showing here is the bottom graph is the original f of x, and the top one slightly above it is f of x plus 2. So what's happened is, you can see f of x has been shifted up 2 squares. Right? I'm going to look at the two graphs in a bit more detail. You got the f of x, and then you got the f of x plus 2. Just look at one of the coordinates on f of x. Just look at that one there. The lowest point of that graph has got a coordinate of -1, -2. -1 along the corridor, -2 down the stairs. And the lowest point on the other graph, f of x plus 2 graph, is also -1, but it's 0 up the stairs. Okay, just check the coordinates. You can see it's -1 along the corridor for both graphs. But when it comes to looking at the y-axis, it's gone from -2, that there, it's gone from -2 all the way up to 0. It's shifted up 2 spaces, right? That coordinate there has shifted up 1, 2 squares up. And that's the effect of f of x plus 2. That plus 2, when you're adding on plus 2 to the f of x, it shifts the graph up 2 places. Right. Now I want to investigate what happens when I want to do f of x, let's say -1, f of x minus 1. So that one there I'm highlighting is the original one. That's the original f of x. Just copy, paste. Right, that's the original f of x, but this time I'm going to subtract 1. You can see what's happened there. That blue graph that you can see is the f of x minus 1. Right, that graph over here, the middle one, the one in the middle, that's the original f of x. And that's been shifted down 1 square to produce that blue graph. So every single coordinate of the middle graph, the f of x graph, has been shifted down by 1. So the middle graph you can see is our original f of x. Remember that coordinate there? That one was, well, that one is -1 and -2. What about the blue one? The minimum point. That one's still -1, so it's not shifted left or right, but it's now -3. It looks like it's gone from -2 all the way down to -3. It's shifted down by 1, and that is the effect of doing f of x minus 1. Now let's have a look at this random f of x. Let's say the graph is that one there, and its minimum point happens to be 5 along the corridor, 1 upstairs, 5 and 1. We're not really bothered about what exactly it is. I mean, here we knew exactly what f of x was. Here, that's f of x, and we don't need to know exactly what it is in terms of x. All we know is that's the graph, that's the minimum point. I want to know what happens to this graph when we apply this transformation f of x plus 2. We know when you add 2, the graph shifts up 2 squares, like so. So that minimum point, every single coordinate on this graph goes up by 2. So as you can see here, this is still 5 along the corridor, this is still 5 along the corridor, right? 5, 5. That's definitely 5 along the corridor, but that number changes now. We do 1 plus 2, it's 3 now. So the coordinate will be, that coordinate there changes from 5, 1 to 5, 3. Let's try another one. Let's try applying minus 5. That graph, that original graph there, let me just highlight this. So we can just see which one's the original one there. That's the f of x. Now if I want to apply f of x minus 5, that one here, obviously that goes down, it shifts down 5 squares. That one shifts down 5 squares. Still going to be 5 along the corridor. Remember, that's 5 along the corridor, 5 along the corridor, 5 along the corridor. But that 1, you do 1 take away 5, which is minus 4. That's the new coordinate. And this is what we call transformation of functions.